My name is DURGA SHRIE and my number is 2240160. In this project, my role is going to be as an implementation specialist.
I'm JING 2240156 and my role for the project is as a test engineer.
My name is Nurul Shafiqah binti FADZIL. My matric number is 2240177 and for this project my role is as the implementation specialist.
Hello, my name is ZUNNURAIN binti NIZA. My matrix number is 2240176 and my role for project as a UI or UX designer.
So this is our project introduction and project scope. So basically, we group 1 were assigned with sub-project 5, which we need to calculate how important the total 8 impact values such as food, clean water and medical supplies impact the humanitarian strength to support human life based on the importance of each aids. So as we know, the medical supplies, which is the most crucial aids, were assigned with 50 as a constant value. The clean water, we put 5 as a constant value, and for food, we put 10 for the constant value. So when we add up it together and multiply it with how many each supplies were brought there, so we can calculate in numbers on how many it impact the human lives and support the human's life when the supply was arrived in the affected area.
Okay, now let's take a look at the code structure, initialization and startup. This phase is critical because it sets the environment where our program lives and ensures that the very first thing the user sees is both functional and aesthetically consistent. On the left, we can see our data segment. This is where we have defined our visual assets, including the Sumut Fatila sheet art using ASCII characters. To bring this to life, we look at the code section on the right. You notice two key initial steps. First step is segment initialization. We use push CS and pop DS to ensure the data segment DS register points to the correct location in memory. Without this, the processor will not know where to find our string or art. UI triggered. Immediately after we call the set low sort routine, we choose to trigger this before any test is sprint to establish the Sumut Fatila routine right from the start. Beyond just visuals, we have implemented two features to make the system feel alive. The first one is audio boot sequence to give the user a tactical confirmation that the system is operational. We use a loop and the ASCII bell character 07H. This creates a triple beep sound as the system powers on. The second one is user interlock. Finally, we don't want to rush the user. We have implemented press any key help user interrupt 21H. This acts as a gateway, ensuring the user has seen the splash screen and is ready to proceed to the main dashboard. By combining this low-level memory management technique with international user experience design, we ensure that the system starts up reliably every single time. Moving on to the visual foundation of our system, the blue screen and the border algorithm. On the left, you will see the set blue screen routine. This is low-level assembly using BIOS interrupt 10H. The first block clears the display. The value 1F is key. It defines our color attributes. 1 for a blue background and F for bright white text. The second block resets the cursor to the origin 00. This ensures that every time the system updates, the UI starts from a perfectly aligned blank state. The system impact. Beyond just aesthetic, this algorithm is responsible for interface reconstruction. It uses extended ASCII characters to draw structural border and menus. By automating this process, we ensure that whether the system is displaying a warning or a menu, the layout remains consistent, organized, and user-friendly. The UI begins with the set blue screen routine. This ensures a clean, consistent visual state by clearing the screen and applying the blue background theme every time the menu is accessed. This step is critical for preventing visual clutter from previous operations. Displaying the interface relies on modular memory handling by moving specific memory offsets for the header _MSG and menu _MSG into the DX register. The system can independently render theme information and navigation options. This structure allows for easy updates to the UI text without altering the core logic. User interaction is handled via interrupt 21H for function 01H. This instruction halts execution to await a single character input. The capture value is stored into the AL register, which serves as the trigger for the program's decision-making logic. Decision-making logic, a series of CMP, compare, and JE, jump if equal. Instruction function as a switch case structure to direct program flow. Inputs 1 and 2 route the user to the warning animation subroutine. Input 3 direct to the system to the calculate impact subproject. Input 4 execute and exit sequence. This structure ensures that each user choice is mapped to a specific isolated memory address for execution. Error preventing instability. The navigation concludes with an unconditional JMP main menu instruction. This serves as a safety else care if an invalid key is pressed. The program automatically reloads the menu interface rather than crashing or terminating unexpectedly. This creates a continuous stable loop for the end user. The presentation now moves to the impact value and display section, which focus on the core data structure and user interface element of the program. Data initialization, the weight. The calculation logic begins with the weight level. Using the DW defined words, directive fixed impact values are set to 10, 5, and 50 for each category. These are 16-bit numerical values, providing the necessary precision for the humanitarian impact calculation. User interaction and string definition is user prompts are defined through label P1, P2, and P3, which store the text string seen on screen. Each string incorporates ASCII codes 1, 3, and 1, 0 for carriage return and line feed to move text to the next line. Additionally, every string ends with a dollar symbol, a mandatory terminate that tells the processor where the text ends. Memory efficiency, the pointer array is to optimize the code. A prompt level stores the memory offsets of this text string. By organizing these offsets into an array, the program can use a loop to display prompts sequentially, making the overall code shorter and more memory efficiency. Finally, the total _MSG and suffix _MSG are decorative strings that use equal signs to create a clear result box in the console. This ensures the final calculated impact is presented in a structured and professional user format for the users.
At this part of the program, we will handle the user input for the menu options. The program waits for the user to press a key using the DOS interrupt INT21H with AH is equals to 1. It then checks which key was pressed. If the user selects either option 1 or option 2, right, the program jumps to the warning animation section. In this section, which displays a blinking warning message and emits a system beep to indicate to the user that the option is unavailable. After the user presses the key, the program then returns to the main menu. Now let's take a look on what happens when the user inputs the option 3. The program then enters the calculation impact section. Here the screen is cleared and the header becomes visible and to provide a context. We then reset the total impact value to 0 using the exclusive or XOR destination index to destination index and clear index for looping using exclusive OR using the source index to source index. Next, let's enter into the program's calculation loop. As we can see in this coding, alright, we are going to talk about how the calculation is going to be handling all 8 items. Firstly, in our display, it's going to show us all the current items such as food kits, water liters, or medical boxes. And we are going to use the move prompt plus SI into the data register and call the print str. The user input is later read using the call write number, as we can see. Each input is going to be multiplied by its predefined weight using the multiply or mul instruction. And the predefined weight has been explained, if I'm not mistaken, by Ayin in the previous slide. And the result is added to the running total in data register with the add instruction or addition instruction. The source index is then incremented to the next to move to the next item, and the loop continues until all 3 items have been processed. This way, we don't have to do any manual calculation. This program calculates for us the total 8 impact value automatically. The further embedded subroutines in this program is going to be explained by my teammate.
For this part, I will explain to you on how the conversion of the ASC2 character into numerical value happen. So as we know here, there actually is 2 parts that make this works, which is read number and our loop. So for read number section, it's basically start counting the digit from 0 and clear the big X from any digit before. So you not use the old digit that we keyed in before. And as you can see here, for our loop, first of all, it's wait for the user to input the data by pressing the key press, and it will display the data that will be keyed in. And then when the enter key press will press, it show the input will finish input by the user. So after that, it will change the ASC2 character into the numerical value by building the multi-digit numbers, and then store the new number, shift it to left and add new digit to the number and go to read another digits. This part is very crucial, so the numerical value is not become different from what the ASC2 character that the user key in, to avoid it from being different. That's why this process was made. And for the RDAN that were included in this slide is to tell us that after the final result was achieved, it will key in all the input inside the AX, and then it will return back to where the main program interface. So basically, this process is crucial for changing the ASC2 character that were keyed in by the user from the keyboard into the numerical value, so the computer can calculate with it. For this section, I will explain to you on how the conversion of the numerical value into printable ASC2 character happens. So as we can see here, there's a 3 part that make it work together, which is print num, p loop 1 and p loop 2. As you can see here, for print num parts, basically we start, the function of it is to start counting the digit from 0 and print the number to decimal, which is we need to convert it. It will be converted to base 10. For p loop 1, the division process occur here in the program. It will be happen like it will be divided stack by stack. So it can be converted into the ASC2 character from the numerical value. So basically for the payload 1 is actually we use to fix back the reverse remainder, which is the product of the division that was very crucial to make it into the accurate ASC2 character. For payload 2 section, it's print the correct digit that already been done at payload 1 from the step before and print the ASC2 character inside the screen in the decimal, which is ASC2 character, so the human can understand it. So this part also was one of the crucial part of the code because it convert back what that already the numerical value that already been calculated by the computer back into the ASC2 character as an output. As we know, the IMO 8086 only can display the character, which is ASC2 character. That's why the payload 1 and payload 2 section was very crucial for this project.
To test whether our program is correct and accurate, we are using manual calculation to prove it. An impact value is a constant that we set. By multiply with the user input quantity, we calculated the total impact. For example, we are using 111 for food kits, water liter, and medical boxes as our user input quantity. 10 will times with 1, 10, 5 times 1, 5, 50 times 1, 50. So the total impact will be 65. By comparing the program output, we will realize that the output is completely matching with the manual calculation, which verified that this program is successfully implemented. For the output display, from the start, move dx offset total MSG, which means pick up the label, and move the text of total impact into dx. Call print str, it will print the text to the screen that user know what the number represent. The final calculated total impact, which will store in di, will move to dx for printing. Call print str will send text onto the screen, while call print number is to convert computer internal maths into a number that can be read. For the purpose of returning to the main menu, move dx offset press MSG is to find the text of press any key to return, while move AH8 actually it means stop or wait until the user press a key. Once it press a key, the function of jump main menu will let the user go back to the main menu display. While for the program to terminate, move AX0600H will paint the screen to black background and text in white. While the end, RET, which means return, as the program has officially finished and the program is end.
This is going to be the program's demonstration. First, once we've clicked on emulate, we will press on run. And then later we will be shown a display of a blue screen along with our ASCII art of a Summit Flotilla with a boat, ship and a human with a welcome text of Summit Flotilla 8 management system with its SDG 16. Once you press any key to start the system, we will enter into the main menu navigation, which at the top we will again have our title along with the SDG 16, and at the below we will be shown the team members' details such as their full name, matrix number along with their roles. And below of that we will be shown a main menu where we have shown the first, second, third and fourth options to choose, and we will also shown to ask the user to input any choices over here. Let's say if the user presses 1, it brings them to each section where it displays them the red animation of showing option unavailable, press any key to return. And when the user presses on any key, they will be written to the main menu again. And the same thing applies again for option 2. Now let's go to the option 3. In option 3, once we have entered, we will be bringing to a different kind of section where the header is now cleared, and we are asking the user to input values for all 3 8 items, starting with food items. Let's say we go with number 1. And second also 1 item, third also went to 1 item, and it will show us the total impact value, which is 65 based on the multiplication of the number of items entered with the value, which is 10 for food kits, 5 for water liters and 50 for mat boxes. Once done, again when the user presses on any key, it returns or brings them back to the main menu. Now when they again enter the third option and go with a very exceeding number of items or amount of items, let's see what really happens. Here we are entering multiple lines for food kits, water liters, and it's also going to be happening for our medical boxes. As we can see, the total impact value that was given is 65,471, and this is basically our limitation. And when the user presses on the any key, it brings them back to the main menu. And now when they press on fourth, it will exit the system and shows the program has reached control to the operating system. And that is the demonstration on how our entire project works, where only third option is available, and first and second option is going to be dummy, and fourth basically ending or terminating the program and bringing back to the operating system.